Hello. In this recording, we will do an example problem which utilizes Ohm's law, Kirchhoff's voltage law, and Kirchhoff's current law. We may also calculate power, but I don't think we are in this problem. We are looking at learning objective number 2, which is to be able to state and use Ohm's law, Kirchhoff's current law, and Kirchhoff's voltage law, and be able to use these laws to analyze simple circuits. If we do have to calculate the power in this one, oh yeah, we are. So we will also look at objective number 3, which is to know how to calculate the power for a circuit element in a simple circuit and be able to determine whether or not the power balances for the whole circuit. I don't think we're balancing for the whole circuit though. We'll just be looking at the power, calculating the power in one element of the circuit. Okay, let's first start with what is Ohm's law? Ohm's law states that the voltage is equal to the current through the element and the resistance in the element. Kirchhoff's current law says that the sum of the current into a node is equal to the sum of the current out of the node. And Kirchhoff's voltage law says that the sum of voltage in a loop is equal to 0. Okay, so let's take a look at this circuit. It says for the circuit shown, calculate this current here, I sub 5, this voltage, and this voltage, and then we will look at the power delivered by this voltage source. All right, well, what do we know about this? We know the polarity of the voltage, V sub 2, and using the passive sign convention, I sub 2 would go from positive to negative. And we know the voltage polarity of V sub 1. I guess I should have started with V sub 1. So the polarity of the current with I sub 1 goes from positive to negative, so it would be in that direction. Now if we look at voltage, or Kirchhoff's voltage law, we would have the current in the loop start at this node and go in this direction. So I like to do the clockwise direction and return to the node that we started at. So we'll call that current I. And I'm going to bring it over here a little bit. Okay, maybe I should have, well, you can see. I'll move it a little here. Let's see. Because we don't want to cover up our polarities. There you go. That way you can see the polarity of voltage too. All right, so let's start with Kirchhoff's voltage law. So apply KVL at loop. We only have one loop. So we'll start at I at this node. And so we have minus 24 volts. Then we come around here, plus V2, V sub 2, keep moving clockwise. We come to the 7 ohm resistor, and we're entering at the positive terminal, so it's plus V sub 5. And we keep moving around, and we're entering at the negative terminal for V sub 1, so it's minus V sub 1. And that brings us back to our starting node, so that is equal to 0. We can change this and we can apply Ohm's Law and use our single current that's in the loop, current I. So we would say minus 24, and V2 could be expressed as 3I, and voltage 5 could be expressed as 7I, and voltage V1 can be expressed as 2I. So it'd be minus, do we make that a plus? Because this would be a plus as far as I is concerned. So that should be a minus I, so we'll make it a plus. So that's 5 plus 7, which is 12I, is equal to 24. We'll move this guy over to this side. So I is equal to 2 amps. We're looking at problem 2.5. I'm just going to go with it. All right. So if I is equal to 2 amps, we can see that I sub 2, so this is I, and let's say it's coming into this node, and I sub 2 is leaving at that node. So coming in is I, going out is I sub 2, so that's equal there. At this node we have I sub 2 coming in and I sub 5 leaving, so I sub 2 is equal to I sub 5. So we can say I sub 5 is equal to I. So we have an answer for I sub 5. Okay, so that's A. All right, now we want V sub 1. Okay, so at this node, I sub 1 is coming in and I sub 5 is coming in. So I sub 1 in, so I sub 1 is equal to minus 2 amps. They're both coming in. There's 2 amps. Okay, so V1 is equal to I sub 1 times 2 ohms. And V1 is equal to minus 2 times 2. V1 is equal to minus 4 volts. All right, so that is B. I'm going to change color here. Let's go with purple. So C says find V sub 2. So V sub 2 is I sub 2 times the resistance, which is 3 ohms. And we said I sub 2 was equal to I. So V sub 2 is equal to 2 amps. times 3 ohms. V sub 2 is equal to 6 volts. Okay, D. Find V sub 5. V sub 5 is equal to I sub 5 times 7 ohms, the resistance. So V sub 5 is equal to 2 amps times 7 ohms. V sub 5 is equal to 14 volts. Okay. Now we'll find the power delivered by the 24 volt source. All right. We know the current here is equal to 2 amps. So power delivered is minus V times I. It's entering the minus terminal, which is minus voltage is 24 volts and current is 2 amps. So power is equal to minus 48 watts. All right, what does the minus sign tell us? It tells us delivered to the circuit. Therefore, the power delivered to the circuit is 48 watts delivered or supplied. All right. I think we'll call it quits here. The end.